Let us have an understanding on SparkSQL shell. Within bin, there is a command spark-SQL which will provide a shell-based access to provide the SQL command, and I can operate almost every SQL-based commands against the data. I can start the SQL shell as a local mode, or I can connect to the master by providing the Spark master. Let us see both the options. Let me start the SparkSQL shell in the local mode and see how it behaves. I have the Spark installed in this specific location. Within bin, I can start the SparkSQL shell. Before working with the SparkSQL, we need to have an understanding on how the metadata would get stored within the Spark, and it works the same way how it works within Hive. As a quick revision, let us have an understanding on how the metastore is organized. SparkSQL uses a metastore. Either it could be a MySQL database, Oracle, or any RDBMS, and by default it comes with a Derby database. We don't need to do any configuration. The location where we are starting the shell, in the same location this particular metastore that is using a Derby RDBMS would get started. And the actual data would get stored within either HDFS or S3, or it could be any storage. Since I have started in the local mode, I have not mentioned any specific location for the data warehouse. By default, it would get started in the same location where I have started the shell, that is within the bin folder. Within bin folder, the metastore would get started, and that would be made with a Derby database. The disadvantage with the Derby database is only one user can access that particular database. We cannot have multiple user sessions. In case if we wanted to have multiple user sessions, we need to have an RDBMS setup with MySQL or Oracle or any other RDBMS. That would be taken care by the administrators. Within the SparkSQL shell, I'm going to use the commands show databases. It would show what are all the databases that I have within this specific metastore. Metastore would store only the meta information, and the actual data would get stored within the storage like HDFS. Let me drop this database and create a new database. I'm going to drop the database. Cascade would drop all the existing table within that specific database. Now let me create the database. This would reserve a folder within the warehouse location, that is the storage location, to retain all the data. Let me describe this specific database. It's going to use this specific location to retain any data about this particular database. Database is made of n number of tables. Let me create a table. I can get into this location and check, do I have any content? I don't have any content. So let me create a table. I'm going to mention how the data for this particular table would be used. For that, we need to have an understanding on the schema on read versus schema on write. A normal database, generally it would use the schema on write option. That is, whenever you're going to insert a data into a database, it would verify the data whether it is matching with the schema. If it matches, it would get inserted. Otherwise, it would throw an error. So on insert, it's going to use two steps. One, verify the schema, and two, insert the data. Since it is going to verify all the data within the RDBMS will be only verified data. And I can read the data back from the RDBMS. So I'll be getting all the verified data from the RDBMS, and read, it would do just only one step. So most of the time within RDBMS, read will be faster than write. And within SparkSQL or in Hive, any data that I am going to add, it would just get stored within the storage. It would not be verified with the schema. While reading, the data would be verified whether it is matching the schema. If it matches, it would produce the result. Otherwise, it would replace it with null. It would not impact the data that is stored within the storage. Let us see this with an example. While creating the table, I would mention the schema. I'm going to create a table called employees. Within the database mydb0. So it would reserve a folder called employees within the specific location, and it would read the rows within that particular file as each and every line as a row, and it would be delimited with comma, and it is going to have two columns, that is name and age. So it's going to reserve this specific location as the data storage for this specific table. I can add it through the SparkSQL, or I can add it through a normal command and copy the file into this specific location. So I would see a folder employees. Now I can provide any SQL command against this particular table. Since I don't have any data, it would not return any result. Now let me copy the data into this specific table. I have a sample file content. So I have 3 rows. It's comma delimited. I have name and age. I'm going to load this particular file into this specific table. I can use the SparkSQL shell to load the data. Load data, which is available locally in this specific location, into the table mydb0.employee. It's just going to copy the data into that specific location. I can verify. Let me get into the folder. The data, it would get copied as it is. So while reading, it's going to read the entire data. Let me select the records from this specific table. So I have got 3 rows. And here I have data as ABC. The actual data, it would get stored, but it cannot infer that as an integer, because while defining the table, I had mentioned the second column that's going to be of type integer. So it would replace that with a null. So this is a proof it is going to apply the schema while reading the data. I can even copy the data directly into that specific location. So I'm going to copy the file into this specific location with another file name. So I have 2 files now. So both the files would be considered as a source for this particular table. So whenever I am going to get the records, it would consider both the files. So I am getting 6 rows now. I can fire any query that I want. Almost every query that we have in a normal SQL, it would work. It got the result. For every activity, it's going to schedule a job. We can verify the job through the web UI in port 4040. For every query, it would trigger a job, and we can see the details about how the job got triggered, and automatically it would schedule the job accordingly, and all the low-level API would get executed to get the result. We can see the details on how that particular task got executed, what is the event timeline, what are all the RDD internally it got created. All those details we can get through this web UI. So when the SparkSQL is getting started, automatically the web UI would get started in the port 4040.